4i squared over n squared. And what's our delta x? 2i over n. No, it's just 2 over n, right? You're right. Okay, that's a big step. We set up our summation. Now, how do we deal with the summation? Let's do a little bit of algebra. We're going to have the sum as I goes from 1 to n. 2 times 4 is 8. That's 8 I squared over n cubed, right? Now this sum, notice what the sum is talking about. What is the sum effect? Should say, what is happening with this sum that is affected by this sum itself? Specifically. And probably a tough question to answer because you think everything is affected. Well, we know it's going to be 8 plus 8 plus 8 plus 8 plus 8. 8 times whatever. And then n times n cubed times whatever. But what is changing every time is the I, because it's an I squared. So when I is 1, it's 1. When I is 2, that's a 2. When I is 3, it's a 3. So what we can do with this is we can factor out the 8 over n cubed, and we have the sum I goes from 1 to n of I cubed. Oh, that's I squared, I'm sorry. Okay, now last class, we talked about this, some sum formulas, didn't we? So what is the sum formula for something squared? Like an n squared or an I squared in this case. So if I'm looking at just this summation right here, there's a sum that I can get out of that. Notice it goes to n. Anyone have any recollection? Wasn't it n times 2n? No, it's n times n plus 1 times 2n plus 1 all over 6. I don't know about you, that just was I thought a huge step going from a summation to this. I can deal with this. I can do algebra now and deal with this. This doesn't stress me out nearly as much. There's a little bit of, work here, algebra to multiply out and reduce. But what do we have here? We have 8 over n cubed times, and if I multiply this numerator out, I'm going to have a 2n cubed plus 3n squared plus n all over 6. Yes, no? Yes. And now let's just take this another step further. I'm going to multiply the 8 over n cubed through. And maybe it's helpful just to also realize this is like 8 over n cubed times 2n cubed over 6 plus 3n squared over 6 plus n over 6. So if I multiply the 8 over n cubed through to each term, I'm going to have what? 8 times 2 is 16. So 16n cubed over 6n cubed plus 24n
n squared over 6n cubed plus 8n over 6n cubed. And so if I reduce those down, I'm left with 8/3 plus 4 over n plus 4 over 3n squared. So that doesn't look very bad at all. 8 plus 4 over 8/3 plus 4 over n plus 4 over n. I feel like, wasn't there a minus? No, it wasn't a minus. 4 over 3n squared. Okay, so we're almost there. We've done 99% of the work. The last part is to fill in the first part of that formula, that the integral from 0 to 2 of x squared dx was the limit as n goes to infinity of the sum as I goes from 1 to n of f of xi delta x. And we've done this part. We've done that. That's going to be this 8/3 plus 4 over n plus 4 over 3n squared. So what's left to do is to say the limit as n goes to infinity of 8/3 plus 4 over n plus 4 over 3n squared. I'm asking myself, where did I get the... I think I have a mistake in my notes. And as n goes to infinity, we have 8/3 plus 4 over infinity, which is 0, plus 4 over 3 times infinity is still 0. So just 8/3. And we actually found the exact area under the curve by doing that. That was a very long process, and we won't be doing long processes for very long. We have a few examples in this section where we do them. And then in the next overall section, not the next subsection, we get into the fundamental theorem of calculus part 2, where we can cut that way down. But once you understand this limit process, this infinite sum process that's going on, and if we go through that, we can use those formulas we had, the sum of n, the sum of n squared, the sum of n cubed, the three we're going to be dealing with, and how they lead to this kind of result. So if you're feeling like, oh my gosh, why just so much? Everyone feels that way, and I feel that way too. And I really would almost like to skip this section, but I feel I need to cover it to be true to you. I'm not going to say I'm doing it for your own good, but we're doing this section because we should cover it so you understand that process. So just to recap that, I have another example we're going to do, but just to recap, what we've done here is we took, looking for this integral, so we treat the integral as an infinite sum. So we start the sum process, we find our delta x, we find out what those xi's are going to be, we put them in here. You know, this right here is our f of xi, and there's our delta x, and we bring them together, we pull out what doesn't have an I, leave the I inside, that infinite I, or the I from 1 to n is I squared is going to add up to be this expression. We do the algebra, we play around with the algebra a little bit. In every case, though, it should be that you end up with one term, and then other things have n's in the denominator, and the n's will go to 0. I don't think we're having any cases. There could be the odd case that comes up where you still have an n up top, and you end up with it goes to infinity, but I don't think we're going to be dealing with that. So if that happens, something probably went wrong, because we're doing definite integrals. And then after you get your everything in terms of n's, you take the limit as n goes to infinity and makes all those things at the end of the denominator go away. You're left with that first term. So fun stuff. Let's do another one. Any objections? Okay. Use the definition of the definite integral to evaluate the integral from 0 to 3 of 2x minus 1. This one's a little easier because we have a 2x, and we know what that sum is. That sum as I goes from 1 to n of I is going to be n times n plus 1 over 2. We know that one. That was what Gauss came up with when he was a kid. So let's start off. Our delta x is going to be that 3 minus 0 over n, so 3 over n. Our xi is going to be the left interval 0 plus I times the delta x. So it's going to be I times 3 over n, which is 3I over n. So our f of xi so that's our xi term. Our f of xi is going to be 2 times 3I over n minus 1, which is 6I over n minus 1. So we put this together. So the sum as I goes from 1 to n of f of xi delta x is going to be the sum as I goes from 1 to n of 6I over n minus 1 times the delta x is 3 over n. So let's split this up a little bit. Let's distribute the 3 over n. We have the sum as I goes from 1 to n. We only had a single term last time. We have 2 this time. 18I over n squared minus 3I, just 3 over n. And we can make this into 2 different summations. I goes from 1 to n of 18I over n squared minus the sum I goes from 1 to n of 3 over n. Okay. So look at that first term, the 18I over n squared. What can you factor out of that? Or what can you take out that is not an I? What can come out of there that's not an I?
18 n squared. 18 over n squared, I would pull out. And here, I mean, I would just pull the 3 over n out, but what goes left inside, I guess, a 1.
You could do that. So we have 18 over n squared times the sum as I goes from 1 to n of I minus the sum, we could do that, 3 over n, not that you're asking me to do it, as I goes from 1 to n of 1. And now we know those infinite sums, or that, no, I shouldn't say infinite sums. We know the sum up to n, 18 over n squared. That I is going to be n times n plus 1 over 2. Adding I from 1 to n is n times n plus 1 over 2, minus 3 over n times what? If you add 1 plus 2 plus 3, 1 plus 1 plus 1 plus 1 plus 1 plus 1, adding that up n times gives you n1, n1, so it's just n there. So now we get to play with the algebra. We got it out of the summation stuff. Now we get to play with the algebra, and then we can take a limit. So it's kind of a 4-step process. You can set up your summation of all little parts, work through the summation, get it over to out of the summation into the ends, and then do your limits after you do the algebra. So this is going to be 18 over n squared times n squared plus n over 2 minus, and this is 3n over n. I think you can see what's going to happen there. So that's going to be 18 over n squared times n squared over 2 plus 18 over n squared times just n over 2 minus the 3. So these n squareds divide out. That's n over 2. Okay, and so the n squared divides with the n, leaves an n down below. So we have 18 divided by 2. What happened? Hit the wrong button. There. That's going to be 9, isn't it? 9 plus, and then we have 9 over n minus 3. So if we take the limit as n goes to infinity of this, what's 9 minus 3? 6 plus 9 over n. So it's 6 plus 9 over n. It's going to be 6 plus 9 over infinity, which is 6 plus 0, which is 6. I've got one more messy one like that. Then we're going to do a couple of, I think, fun things. I think they're fun because they're more area based, more visually based, more geometrically based. How's that? You like geometry? Okay. Find a formula for the Riemann sum obtained by dividing the interval 1 to 2 into n equivalent subintervals and using the right endpoint for each ck. I don't know why they keep changing notation. Then take the limit of these sums as n goes to infinity to calculate the area under the curve for f of x equals 8x from 1 to 2. So what do you think our delta x is going to be? Yeah, 2 minus 1 over n, so 1 over n. And then our xi, this is going to be a little different than last time. Up to this point, our left endpoint was 0. Now it's a 2. So we'll say 2, no, it's a 1. And I worked that all out wrong. It's going to be 1 plus I times 1 over n. So it's 1 plus I over n. So when we're looking at our f of xi, we're looking at 8 times 1 plus I over n. Did I make a mistake?
No, I was asking where the 8 came from.
Yeah, it's from here. So that's going to be 8 plus 8i over n. So we go to our summation. It's summation phase now. I goes from 1 to n because it's right endpoint sum of 8 plus 8i over n. Okay. Pull the 8 out, I guess, on the first pair. Second pair, I can pull an 8 over n out, and I goes from 1 to n. Oh gosh, I made a huge mistake and no one caught me. I don't blame you though. Sorry, huge mistake, huge. I forgot to multiply by my delta x, it's 1 over n. Sorry about that. Now that I made the mistake, you don't have to make the mistake. Okay, now we're better. So Out of the first pair, if I pull the 8 over n out, I just have the sum I goes from 1 to n of 1. Out of the second pair, I can pull the 8 over n squared out, and I have the sum as I goes from 1 to n of I. So what is that sum? I goes from 1 to n of 1. If you add 1 n times, how many, what do you have? N, thank you. And if you add I, 1 through, if you add 1 plus 2 plus 3 all the way up to n, what would you have? The sum of an I, not an I squared or I cubed, n times n plus 1 over 2. Okay, we're out of summation phase. We're into simplifying the n's. That's 8 plus 8 over n squared times n squared plus n over 2. I just want to reduce that to 2 and the 8 right off, if you don't mind. So we would have 8 plus 4n squared over n squared plus 4n over n squared. 8 plus 4 plus 4 over n. And our last, oh, I guess we can, what is 8 plus 4? Anyone know that? 12, good. So now we're going to take the limit as n goes to infinity of 12 plus 4 over n. It's funny, a process that early in the semester would intimidate people. They're probably now saying, yeah, we're at the limit stage. That's the easy part. And that's going to be 12 plus 4 over infinity, which is 12 plus 0. So I get 12 out of that. Okay, fun stuff. Okay, who wants to see something, some problems now? We can look at it more from an algebraic or a geometric point of view. Geometry, who likes geometry? Okay. First one's you're probably gonna get mad at me when I show you the first one because you're gonna think that doesn't make a lot of sense. So, here we go. So use the formula of the area of the circle to evaluate the integral from 3 to 6 of square root of 9 minus x minus 9 minus the quantity x minus 3 squared dx. So when you see something like that, set it equal to y, because you can say that f of x is y. So if y equals the square root of 9 minus the quantity x minus 3 squared, and you square both sides, you end up with a y squared equals 9 minus the quantity x minus 3 squared. And if you bring this over, you end up with x minus 3 squared plus y squared equals 9. What's that the equation of? We know what that's a formula for? Well, yes, but yes to both because the circle is an ellipse. Yes, it is specifically a circle. Now, this definition up here would imply the semicircle, the upper part, because it's not negative. Negative would be the lower part. So we'd have something like this. Because it's x minus 3, it's going to be shifted over 1, 2, 3. So the center is there. And what's the radius of that circle? Any idea?
3.
3. Good. The square root of 9 is 3. So it's the square root of 9 here. So that's going to have a radius of 3. But if you look at the limits of integration, they want us to go from 3 to 6. So what they're really talking about is the area from here to here, all this area. So what is the formula for the area of a circle? And what the formula for the area of a circle is?
Pi r squared.
Very good, pi r squared. And this formula, this graph would only give us the upper half because you couldn't have the lower half. It wouldn't be a function, wouldn't follow the vertical line test. So in this case, the area we're talking about is going to be pi r squared over 2, but we're not doing the whole circle. We're doing it from 0, not 0 to 6. We're doing it from 3 to 6. So how much of the circle are we really talking about? A quarter of the circle. So let's go ahead and get rid of that 2 and make it a 4. Now, do we know the radius of the circle?
Yes.
What is it?
3.
3. So what do we have? 9 pi over 4. So you could say in this case, the integral from 3 to 6 of the square root of 9 minus the quantity x minus 3 squared dx is 9 pi over 4. And that's it. That wasn't so bad because we have geometry to fall back on. The next one's very similar. And I would like to jump into the next section, but I'm happy to start the next one off with you. So the next one says use the formula for the area of a trapezoid to evaluate. So anyone know the formula for the area of a trapezoid? 1/2 base 1 plus base 2 times the height. And the bases are the parallel sides. So if you were to draw this graph, draw a picture of what's going on here. 2x plus 3, and then it starts at 2 and goes to 4. What's 2 times 2? Plus 3? 7. So it's going to start here at 7, and then 2 times 4 is, plus 3 is 11. It's going to go up here to 11. So we're going to have this shape here. And we're talking about the area under this curve. And a curve doesn't always have to be a, parabola or anything. A line can be considered a curve. So we want this area under the curve. But that happens to be the shape of a trapezoid. So what would you call the length of the parallel sides? What are they going to be? Seven and 11. So we'd have 1/2 times 7 plus 11, and then the height is this part here. That's the height. How far is it from 4 to 2? 2. So 7 plus 11 is 18. So just 18. Doesn't always have to be bad.